the development and marketing position of Red Look Technology, involving AI analytics, software, and infrared cameras for the oil and gas market. Sensia and Viper maintain a strong business relations focused on the U.S. market. Thank you. I'll pass it off to you. Thanks, Francisco.
Thanks, Joe.
Yes, no problem.
Well, Francisco Cortés. Thanks. But we are here. Hi. We are here with our business partner, Viper Imaging, so you can learn more in their booth, okay, just here. And, well, thanks for coming, all of you, okay. And, well, this is my presentation. I'm going to talk about all of these topics. I will start talking about the background in gas and flame detection technology, okay, and about what is the role of the infrared imaging and specifically optical gas imaging technology, okay. Then I will introduce what is our value proposition in that field, okay. What is the performance in terms of detection, specifically for methane emissions, okay. And also I will talk about the methane emissions from flares and flaring methane, okay. Finally, I will end with some conclusions, okay, and we'll open the Q&A space. Well, when we talk about gas and flame detection, we traditionally talk about single point detectors. This is the stabilized technology and mainly for, let's say, safety related applications, okay. We can find multiple vendors, okay, for this kind of technology. And we can find different detectors and different technologies associated, okay, like triple infrared, UV, double infrared, or a combination of UV and infrared for flame detection. It also happens the same in the space of gas detection, okay. Here we have different offerings, different technologies like electrochemical, infrared as well. So again, this is the stabilized technology for the last, I don't know, 30 years or so. This instrument is based on a single element, so we do not find any image on them, okay? It is mostly safety oriented, so they are oriented to, well, to monitor the level of risk, okay? So that's why the quantification associated to such as kind of technology is more related to ppms in the case of the gas detection. Here we have some example of a gas detection. Covering a large area requires a large number of detectors, single point detectors, okay? Also, we find a very high dependability on the weather conditions. So it is really conditioned by wind, okay? If we have a detector here, single point one, and we have a gas leak here, if the wind is going in this direction, this detector will never find that gas escape, okay? And also the good point is that dot detectors are able to automatically quantify or detect the gas, okay? So the second point in the background, mostly in gas detection, is, well, optical gas imaging technology. I think it's a well-established technology, and we have here some good examples in this conference. Key players like FLIR and Opgal are educating the market and has been doing this job for years, okay? So we have also handheld OGIs, okay? Using both technologies, cool and uncool, okay? So this kind of technologies is doing a great job for gas leak detection, okay? Mostly used in LDIR inspections. I think all of you for sure are familiar with such as kind of applications. So maybe it's not necessary to extend more about this, but, well, again, we have single point detectors for continuous monitoring of gas and flame. And we have on the other side well-established technology based on OGI for handheld, for surveys, okay, and handheld operation, okay. Well, so the third point will be, what about if we can continuous monitoring without continuous monitoring OGI, okay? So this is not so established, okay? Different barriers has conditioned its large-scale penetration, okay? We have two of them: cost of the equipment, because optical gas imaging is an expensive piece of equipment, and also the reliability in terms of false alarm rate, okay? It's not easy. We have thousands of detectors, of single point detectors, which is an FPA, which is an infrared camera. And all of these detectors is providing continuously information at, I don't know, 30 frames per second. So it is not easy to detect without false alarm, okay? Here we have an example of one of our cameras. Installed, in that case, an Amwood sulfuric acid plant for SO2 detection, okay? And here we can see an example about how we do that. In that case, this is a SO2 leak, okay? So taking into consideration all of this background, our view is that there is going to be a technological transition from single point detectors to imaging-based solution, okay? Because the list of benefits for such a kind of technology is much larger than single point ones, okay? First of all, we have cost effectiveness. I think nowadays, infrared OGI solution based for continuous monitoring provide the best, probably the best compromise between protection level and investment required. Because in spite an OGI is even more expensive than a single point detector, you just need one or two, a few of them instead of multiples, okay? The second point we have is the reliability, okay? I think nowadays, thanks to the disruption of artificial intelligence, we can provide a very reliable system in terms of detection, in terms of probability of detection, false alarm rate, range of detection, minimum detectable leak rate, minimum detectable flame size in case you want to detect flames, and so on. Also, the third benefit is the ability to be multifunctional, okay? The ability to be able to detect with the same camera in real time, simultaneously, gas leaks, flames, measuring temperature, detect persons, okay? Even monitor a flare, for example, okay? So we can provide such a list of functionalities with a single system, okay? So taking the advantages of the infrared imaging. Well, for sure, this system, and we have the number 4 and the number 5 benefit is the integrability into a given ecosystem of the distributed control system, SCADAs, or even cloud-based solution, okay? So we are able to integrate around all of this space, okay, in whatever the site and under whatever requirement from customer level. It is a matter just of architecture definition, okay? And also for sure, this technology is very scalable. I mean, you can have, as an operator, multiple cameras located in different remote locations, okay, and having all of them integrated in a single control room, for example, okay. So all of these benefits can provide impact on environmental related application, in safety as well, and also in optimization of the operations. Okay, we can monitor the temperature of our components and so on in order to, well, anticipate failures or, well, carry out a kind of preventive maintenance. Okay, so let's go into details about what an automated OGI can do. So here we have some examples. Okay, before we were talking about multifunctionality. Here we have some examples of this. Okay, so in that case, we can see at the same time how we can see. Well, this is not a gas leak, but this is ammonia spill on the soil. Okay, so we can see the vapors of the ammonia. At the same time, we can track the person. Okay, and this guy is starting a plane here. So that's a great example about the capabilities of the automated OGI. Okay. So again, we are playing gas. For example, we are carrying out tank leveling. Okay, so we can monitor the level of the tank for such as application. Well, it's simple. It's just a matter of thermal contrast. Okay, but at the same time, we can detect the tanks. Okay. Well, leaks, or we can distinguish there is a leak or there is a operational venting, okay, given by relief valves and so on, okay. Well, here we have some other examples. In that case, this is a real leak, and this is methane. We can monitor again multiple people and the methane leak. We are able also not only to detect the methane leak, but also to quantify. Well, here we have another totally different example. This is forest fire detection. Okay. Here we are not running multifunctionality, just detection of long-range detection of forest fire. Okay. So those are the traditional challenges in automated infrared imaging for an attended operation. Okay. Again, poor detection limit, poor detection probability, and an acceptable false positive rate. Okay. So at the end of the day, traditionally, there has been a balance between detection and false alarm rate. And also, it is very important, the price point. Can we do it as in an affordable way? Okay, so can we bring the benefits of the infrared imaging for an attended operation again as in a cost-effective manner? Well, first of all, I want to go deeper into how reliable is this technology. So maybe in some cases, we can be even beyond the human eye performance. I mean, when you are operating an infrared camera, you are watching the image and you can see multiple things. But the way a human thinks and interprets the image, so powerful, and it's so difficult to translate that way into a computer, into a code, okay? But I think we are very proud of this kind of result, that for some specific cases, we are even beyond the performance of the human eye, okay? Here, in this video, we can see, well, very small planes, okay? And we can see multiple pulse stimulus, okay? Here we have hot lamps, filament, halogen lamps, okay? And well, even solar reflections, rating solar reflections, but multiple things that normally activates alerts in other kind of technology. We are able to distinguish flames, a real flame from all of these well, false stimulus. Okay. If you're not a trained operator, news about these hot points and flames. The same happened here. Image that we obtained with handheld OGI, okay? We can see the leak, but we can see many more vapors coming out. So again, we can distinguish where is the real leak, where is the leaking point in such as kind of noisy background. Okay. So again, taking into consideration that at technical level we have broke that barrier, can we do it at reasonable cost? That's the question. So here we need to talk about hardware, not only video analytics, okay? Because the cost driver in that case is infrared technology. So that's why we are integrating two different technologies, okay? Basically, infrared detectors can be divided in two kinds. Cooled, normally operating in mid-wave, sorry, and uncooled, typically operating in the long wave. So we do both. We can deliver uncooled OGI, okay, or we can deliver cooled OGI, okay. Depending on the customer requirements, application, how challenging it is, what is the requirements in terms minimum detectable leak rate or range of detection, we will choose one or the other, okay, with its benefits and weaknesses, okay. So we need to talk about this. And in my opinion, well, I think typically cooled OGI has been the traditional equipment for leak detection, okay? But recent progress on the uncooled infrared imaging and cool technology has been able to deliver technology with enough sensitivity to detect leaks, gas leaks at the end of the day, okay? So let's talk about specifically continuous monitoring and reporting of methane emissions, okay? Here we have a wide offering as well, okay? I'm gonna just give you an example. By the way, we are gonna talk about the methane emissions, like a pure emission, like a leak or so, and also emissions coming from unflared gases, which is today a hot point as well. So here we have an example of system architecture. Okay, so we have the camera, function box, termination box. In that case, we are using for this, in this example, an edge computer where we run software and the analytics. Okay, so connection box directly to the network of the site, if any, but if not, you can connect it to 4G antenna, to a satellite communication system or whatever, okay? Also, you can alerts, Modbus, offices, or whatever. Even you can connect dry contacts and directly send this information to other equipments, okay? So we can offer multiple options of architecture, because at the end of the day, every customer is totally different, okay? And they have different needs. We can eventually connect video streaming directly to the existing network and operates in a server, okay, directly. And here we have an example of, well, data dashboard, okay, that we can provide as well, okay? This is not RedLook software, this is more like just dashboard. Okay, so we can see camera location. We can monitor peak rate, and we can estimate the emission from the component at source level, and we can estimate as well. Not estimate. We can aggregate all of these data in order to provide a site level emission. Okay, so this system can operate with fan and field. Okay, so you could install it in the middle of your site, going 360. Okay, taking measures of all of your emissions, and can create reports at weekly basis or monthly basis or whatever. Okay, everything is customizable. Okay, this is an important feature as well of our technology. And also a good point here, there we can eventually connect other sources, data sources. Okay, so we can provide information at this level and correlate emission factor with operation factors. Okay, because it's not a matter of just having a survey and having the information from this day at this moment. Okay, so we can have all the information continuously and correlated with what's going on in the plant. Okay, with the activity factor of the plant. Okay, so this is our Red Look technology, by the way. And well, if you want to learn more about it, we have this software in the Viper imaging booth. Okay. And another important topic is the unflared hydrocarbons. Okay, we have a solution to somehow quantify this. Okay, with such as kind of equipment. We have a dual band equipment. Okay, we need to for flare and combusted or unflared gases. We need to have one. We think that around 3.3 microns. Any other hydrocarbon molecule. Okay. These two detectors, we can somehow measure basically, well, the destruction and removal efficiency of the flare. Okay. Here there is a video that helps us to explain how it works. We're using for this video. Okay, Bunsen burner give us the ability to modify the combustion. We can modify the air inlet, and we can modify the amount of fuel that we are sending to the flare. So, for example, here we have closed the air inlet. There is no wind, and the fuel amount is high. You can see here how it degrades the efficiency. Okay. You can see here in red color, we are painting somehow the footprint of the, that is the unburned hydrocarbons. In green color, we are painting the footprint of the CO2. Clearly, in that flare, we should only find CO2 and water vapor. We are not monitoring water vapor. We are just monitoring. Now, in that moment, we have turning on a wind simulator. Okay, so the wind effect help the combustion, help provoke turbulence in the flame. Okay, and that turbulence makes a good mix between air and hydrocarbon. That's why it's the destruction and removal efficiency is high. Okay. So here again, in that case, we still having the air inlet closed. Now we are opening. Okay. No wind condition. The combustion here is perfect, almost perfect. You can see you cannot see actually the plate because it's totally transparent. And here, the destruction and removal efficiency has increased max. Here we can see a larger print of CO2 instead of unburned hydrocarbon. Okay. Here we have an example of a real flare. Okay. Camera film, here we have flare and how it works. Very recently in a Repsol refinery in Spain, and they changed the bottom here to a high efficiency one. Okay. So we were evaluating their performance. Now if you can see, here is we can see the CO2, much larger, let's say, footprint than unburned hydrocarbon. Okay. Well, that's all from my side. In conclusion, we think that the automated infrared imaging is driving the technological transition, again, from single point detectors to imaging-based solution. Thanks to this, we can deliver cost-effective system with higher cost effectiveness. We can upgrade the safety and environmental standards. Okay, we can enable a more efficiency and attended operations of sites. Okay, and in terms of standardization of methane emission measurement and reporting through continuous monitoring, we can monitor components. We can monitor fugitive emissions. Okay, when I said we can monitor components, I'm talking about monitor operational vents as well, emission coming from the operational vents. But as well, in addition to that, fugitive emissions, okay? And also we can measure the emission at site level, okay? Not only at source level. And we can deliver a complete traceability of such as emissions, okay? And as well as we have recently saw, we can quantify the unflared hydrocarbons, okay? And well, that's all. Thank you very much. I tried to explain a lot of things in such a short presentation. I hope it's more or less clear. And now if you have any simple question, I would be delighted to answer.